Hello, welcome back to the third out of the three videos for chi-squared for Geog 300, Geographical Data Analysis at WVU. The first video had the general setup. The second one we looked at how it works within the inferential statistics process. This third one looks again at the kind of the packed principles for chi-squared. And to begin with, many of the same principles apply. So only presenting those pieces of information which are actually necessary for the reader. As always, that depends upon who the reader is. Most of the time, you don't need to put in, I used this formula in Excel. That's overkill. Say you did a chi-squared test. Then say, here's what the p-value is, here's how I interpret that. I interpret that by saying, I'm going to go with the null hypothesis, I'm going to go with the alternative hypothesis. I'm going to believe that my predictions are good or bad, and therefore that how I generated my predictions is informative of what I am studying. That gets to the main thing that is new for chi-squared. You need to make sure you justify as clearly as possible how you get those predictions, because that is pretty much the entire key of the rest of the process for chi-squared. If you use something really silly for generating your predictions, like I'm going to try to estimate the support for a particular political candidate based upon the soil type of a person's where a person lives. That would be silly. There's no reason to think soil type has any effect on voting patterns. So why would you use that as a prediction? Instead, to say, okay, I am going to say media markets are useful for predicting support for different candidates because the television ads are the same for everybody watching within that market. There now is some kind of reasoned insightfulness and reason behind that prediction to say the county averages for a candidate are going to, or the county support for a candidate is going to be close to the average support for the entire media market that that county is in. So I could then use North Central West Virginia market to predict Mon County, Marion County, Preston County, Harrison County, Wetzel County, and have them all predicted the same. And then I can go and say, well, was that a good prediction or not? Maybe it is, maybe it isn't. But I can then at least justify through the example of the ads in the stations will be the same because it's the same television stations people are watching, as a means of saying this is why I think this will be a good prediction. Or you can say, I am picking it very much of a null hypothesis style prediction to say there's nothing interesting. I am going to assume that every single county is pretty close to the statewide average for that candidate. And run that as a prediction and see, well, okay, that was a bad prediction. So that's obviously not it. The other thing to be careful on to limit your statements to that which is in the null hypothesis and the alternative hypothesis. So to take and build upon that last example I just gave of using the statewide average to predict support for a particular candidate county by county, chances are that's going to give you the alternative hypothesis, that those are bad predictions. All you can say is that support varied across the state, that the statewide average was not a good predictor. That is it. You cannot say where it's higher, where it's lower, based upon chi-squared alone. You cannot specify or suggest what might be causing that, because all you put into your prediction was it's the same across the state. You have disproven that it is the same across the state, and that's it. To be very clear, as you write things up, stick to the hypotheses you have. On the other hand, if you say it's by media market, and that turns out to be a good prediction, you can now say, because it was in your hypothesis, that the media markets, and therefore the candidate's advertising, does have a clear effect on what the final votes are, because predictions based upon the media markets turned out to be good. There is a good fit between the predicted value and the actual value. So the main lessons there, again, just to recap, the main lessons for writing up chi-squared: the same principles as before apply, only provide the information that is necessary. Second, you need to make very clear why you are making the predictions you're making. And third, you need to be equally limited or precise in your write-up, in your conclusions and discussions, to make sure you are not claiming more than the statistics are showing. To stick to what is in the null hypothesis and the alternative hypothesis. That going beyond what is in those hypotheses is a common pitfall, not just for chi-squared, but in many ways a common pitfall more broadly in the write-up of spatial analysis and statistical analysis results. So, as always, if you have any questions, please feel free to reach out by email or in class. Thank you again for watching, and I'll see you at the next set of videos.